again to all the New England AI members for coming out, for HackReduce for hosting us, and for Gary King for agreeing to present. Before he gets started, I'll introduce him. Gary King is a statistics professor at Harvard. He is the director of the Institute for Quantitative Social Sciences. He has worked on many difficult and varied problems, and I could continue to talk about all the things he's worked on, but there'll probably be no time left for his talk. So with that, I'll let him get started.
Okay. So thanks very much for the invitation. I really appreciate it. It's really great to meet you all. When I give talks without a lot of math, I feel guilty, and my audience usually really likes it. So I don't have a lot of math, but that's okay. But you should feel free to ask any questions. In fact, if anybody flinches, you'll get a whole lot of technology. Thank you very much. This talk is, the title is Big Data is Not About the Data. Okay. And the media seems to have recognized what we all do. And we used to call it quantitative social science, or some people call it data analytics, or some people call it, I guess, artificial intelligence or computer science. You know, it's like my mom now understands what it is we do because it's called big data, right? But Mom, it's not about the big data. Okay, so what is it about? It's about analytics. It's about what you do with the data. So first of all, the data, just to put us all on the same page, the data in big data, about people anyway. In the last 50 years, the three things that, actually I'm going to put my coat down, I'm going to put this down, and I'm going to take off my coat. I was wondering if I could do that while also holding the microphone, but I didn't think that was going to work. Okay, so in the last 50 years, the information base of the social sciences has pretty much been survey research, aggregate government statistics, and one-off studies of people, places, or events. That's pretty much what it is. There's other kinds of things, but that pretty much encompasses most of what we've learned about people. That's the information base about people. Going forward, as we know, there have been massive increases in new data sources, and there's going to be massive increases in new data sources due to basically doing more of the above, expanded, improved, applied, et cetera. But also, computers are shrinking and disappearing into every little device, and every time something turns from analog to digital, whoever's doing that is very happy because it's accomplishing something, and we all are much happier because it's also spewing out data that we get to capture. There's the replication movement. So not only do we collect data, but much more academics and researchers share data with each other. The White House has now put out 2 memos to government agencies and to granting agencies that said the new default is that government is going to be providing data rather than not providing data. That's just like the United States government recognizes that data sharing is a good thing. Like, what kind of world do we live in now? If you don't know it, you've taken over. Okay, that's really the main thing. It's like you've all taken over. Okay. The barbarians are inside the gates, right? So governments, local governments are competing with each other to share data more and more. I mean, the Obama administration has done a lot of this, but it's quite amazing. There have been amazing advances in statistical methods and machine learning and informatics and software and things like that. What I like to describe to students is that we're all part of something that, if we look back on this time 400 years from now, if anybody's around 400 years from now, we'll recognize this time as a time when we transitioned from looking at things through sort of human intuition, which was pretty good, to using quantification in some way. And there's basically this march of quantification through academia, the professions, government, commerce, industry, and there's even popular books about it. I mean, have you seen Moneyball? Right? You can refer to people to Moneyball, and then instead of, when you sit next to the person on the plane and they say, what do you do? If you don't want to talk to them, you say statistician, right? But if you feel like talking to them, you can say, have you ever seen Moneyball? I do that, right? Just some examples of the data in big data before we get to where the real value is. There's unstructured text. So unstructured text is in emails. Oh, by the way, there's about 4 years ago I saw that there's one LOC of emails every 10 minutes. And you say, well, what's an LOC? An LOC is a Library of Congress equivalent. Right. That was 4 years ago. Okay. And there's speeches and reports and social media updates and web pages and all kinds of sources of unstructured text, which of course is data for us. There's commerce, credit cards. I was in Iceland 5 years ago, and I bought gas at a gas station, and I got a call on my cell phone 2 seconds later from my credit card company saying, is that really you? Okay. Think of how much data they have. Okay. There's RFIDs when you walk through, when you walk out of a supermarket and they say, get back here. There's geographic location in cell phones and fast lane transponders. And if you drive into the garage with one car and you switch the license plate and drive back out, you can't get out because they take pictures of the license plate. Right? There's health information, digital medical records, hospital admittances, accelerometers in your cell phones. And we're only at the beginning. I mean, there's a very small fraction of even health information is digitized. The vast majority of hospitals don't have electronic medical records, right? So you can just imagine what's coming. Full employment for all of us forever, right? The biological sciences, okay, so, I do quantitative social science. Maybe some of you are some of you biology types? Yeah, so there's some of you. We think of you as basically becoming social scientists, right? Because genomics, proteomics, metabolomics, all words I've learned to say and not that long ago. Imaging of all different kinds. Basically what these things are they're basically just doing social science. They're dependent variable. Often of them they're the same. Sometimes they're different. The only difference is that they have something like 3 billion explanatory variables, which is just this trivial little problem. But nevertheless, the unit of analysis is the person. The outcome it has a new name, it's a phenotype, but for social scientists, it's just behavior or attitude or other kinds of things. We're all much more and more doing very much the same thing. Satellite imagery, and not only is it increasing in scope and resolution, but we're getting access to it more and more. There's electoral activity. I'm actually a political scientist, so ballot images, precinct level election results. We have individual level registration of people, like I know their names. I can look up how much money. It's very easy to look up like how much money you've given to political candidates, whether you voted in the last 20 elections, which ones you voted for, whether you voted in the Democratic or Republican primary. And forget privacy, okay? Well, don't forget it. Be very careful about it, because otherwise we're all going to be in big trouble, okay? But we have a lot more information. Web surfing artifacts. I saw Google said it was a few years ago that they collected a petabyte of information every 72 minutes about human behavior, right? And that was a few years ago. Who knows what the number is now? So my favorite statistic is 90% of all data ever created in the history of the world was created in the last 12 months. Right? Okay. So, okay, data's good. Okay, got it. But where's the value in data? So the value in data is in the analytics. So data is easy to come by. It's often a free byproduct. If you have a company and your company has basically any IT improvements, you can have more data later. It's becoming commoditized, so it's becoming cheaper, easier to get, very simple to license for. You ignore it, and if you're in a company or some institution, you're going to have more data at the end of the year than at the beginning. It's just if you don't do anything, you can have more data of more types and more sources. With just a little bit of effort, you can get huge increases in the amount of data available. So where's the value? The value is in the analytics. The output can be highly customized. My favorite is Moore's Law. So Moore's Law is this spectacular thing that computing time and speed doubles every 18 months. And that is terrific. However, I would put Moore's Law against my students or against any of you any day. It's not surprising when a few students come into my office and we increase the speed of the algorithm that runs inside the computer by a factor of 1,000. It's not that big a deal, right? And we can do it in, sometimes you do it in a day. You don't have to wait 18 months to merely double the speed of the thing, right? So it's very nice about Moore's Law, but it doesn't compare to you guys. A colleague came to me recently and said, so I'm running this analysis in Stata, right? And and there's more data now than there was previously, and I tried to run this analysis, and it won't run. Its data says there's just not enough memory. And so could you scope out for us, he didn't come to me, he came to our IT guys, he said, could you scope out for us like how big a computer we need to buy? And their answer was, we figured it out, it's about $2 million, which is a beefy computer, but there are plenty of computers you can buy that cost more than that, so it's not totally insane. However, that's the second part. Oops, where do we go? The second part, oh no, get back. The second part of this was a graduate student and I figured out in about 2 hours that he could run it on his laptop in 20 minutes if we just changed the algorithm, right? This is, these are sort of cool stories, but these should not be a surprise to you, right? You've seen these kinds of things. So, let them talk about Moore's law, that's right, but that's nothing compared to the algorithms. Okay, oops, there we go. So also the analytics is relatively low cost. After all, how much do they pay us, right? It's mostly human capital that you need, which is difficult to come by, but nevertheless. Another important point is that innovative analytics is enormously better than off-the-shelf analytics. So they've been trying to take statistical methods, machine learning methods from the beginning of time, and when I say they, I mean us. We've been trying to take these methods and encapsulate them, make them commodities so that basically they work no matter what. And we've made a lot of progress on that, but nevertheless, even though we can do much better using these off-the-shelf methods than we can not using formal methods, we can often do way, way better using innovative analytics, customized, tuned to the particular problem. So that's really where the advances are. Incidentally, if anybody has any questions, you should ask or scream out obscenities or whatever you like. Okay. Okay. Or don't move or make a sound. Okay. Okay. So here's some examples of what's now possible. Opinions of activists. So a couple of three colleagues of mine wanted to study political activists. So how do you study political activists? They use the standard methods. In fact, an incredibly innovative method. They took a random sample of 15,000 people. They asked them some screener questions. Are you a political activist, basically? Weeded it down to about 2,000 people, and then asked them detailed questions, and then did an analysis of those 2,000 interviews and wrote a very, very famous book. Okay. And instead, but following up on that, a graduate student and I turned to social media. So at the time we were analyzing this was the 2008 presidential election. We were going to look at millions of social media posts, which was really cool. Now there's 1 billion social media posts every 2 days that are accessible. Okay, 1 billion. Okay. So anyway, so what we did, if you think about it, these are millions of, back in 2008, this was millions of posts written by people who wish to express themselves about politics to try to influence other people or places or policies or candidates or things like that, right? So the amount of information was massively more than this very famous book. Anyway, so that's just an example. Suppose you want to know about exercise. The standard way is you do a survey and you say, how many times did you exercise in the last week? Okay? And if you remember, and if you're willing to say, and you actually say, honestly, and that's one thing. But imagine instead we just put a little piece of software in people's cell phones, maybe 500,000 of them, or maybe several million of them, and they all now have accelerometers in them. And we basically indicate how much movement you make, not only GPS, but exactly micro-level movements. There's social contexts, which in academia there have been hundreds of surveys where people say, please list for me your 5 best friends. Tell me their name. We won't tell it to anybody else, and that's sort of a way of how what your social contacts are. Instead, imagine we have a continuous record of phone calls and emails and messages, and the Bluetooth in my cell phone knows when there's another person nearby with a cell phone in it, and it can distinguish another cell phone from a printer or something like that. And it knows day to day whether I walk past the same person, and doesn't know what I say to them, but but we could figure that out. So there's economic development in developing countries. There's government statistics, which in some countries are okay, and in other countries, I don't know if you've ever tried to. I tried to study infant mortality in Africa, where I realized that the World Health Organization, which provided these data, I sort of tracked down exactly like where do you get this number from these countries. Well, basically, it was a guy named Allen who made them up. I mean, he made them up better than anybody else could. I mean, it was really very informed. We wanted to use the data, but really, it was like Allen made up the numbers for like entire countries. Okay. Instead, we can use satellite images of human-generated night at light taken from above, and you can figure things out, or road networks or other kinds of infrastructure. So there's lots more like this. Obviously, we could keep going. So let's recognize, though, that in each case, the fact that there's more data is not helpful. Okay? Some of these data have been around for a while, but what do you do with it? Okay? I mean, if you don't know how to analyze, let's say, 1,000 social media posts, does it help having 1 billion? Right? So what we really need are the innovative analytics to deal with these things. How do you analyze billions of social media posts? How do you analyze the continuous time data from 500,000 accelerometers?
Just a quick question. You mentioned the unique nature of the data from Africa. How much of your time in doing your research do you spend looking at how the data was achieved versus then looking at the data itself?
Yeah, I would say quite a lot of the time. I mean, if I know the exact process that generated the data, then I can model that. But sometimes you get to generate the data yourself. I've run like huge experiments where at least so far as I can tell, I know how the data were generated. But in other cases, we just come upon this gigantic source of data, and we don't really know where it came from, and we have to figure that out. So yeah, that's quite a lot of what we do anyway. Yeah, absolutely. So I'll give you one example. There's a statistic out there that 9 times as many civilians died in war previously, a long time ago, as soldiers. No, I have it wrong. A long time ago, it was 9 times as many soldiers died for every civilian. So 9 soldiers would die for every civilian, and today it's 9 civilian. It's much safer to be a soldier. And so there's many more civilians that die relative to the soldiers. Okay, so anyway, so that's sort of a good thing for soldiers. But basically, where did this number come from? So we traced it back, and there were some citations, and some citations to the citations, and some citations to the citations, and citations to the citations. And we kept going, and we said we're going to find this, okay? Because there was no data source, okay? And we found that Article A cited Article B cited Article C. Article C cited Article A. Okay. We traced it all the way back to this one guy who was the index case, as they say in epidemiology. This one guy, we think he was the first person to write it down, and the week before we got to him, he died. And that's it. I don't know what the answer is.
Was he a soldier or a civilian?
I don't know.
So how do you know if the data is worth analyzed? How do you know the data is valuable? How do you smell that?
Yeah, so in that case, the answer is I don't know. I mean, but that was one number. I mean, in general, what we do is we take the data and we come up with some theory that's a little more general than the data. I'm going to give you some examples of my own research later on. And then once you come up with a theory, then you look for all the observable implications of that theory, one of which is in the data. And of course, it perfectly matches the data because you came up with the theory from the data. Okay? But the key is, can you come up with other observable implications from the same data? Or not from the same data, from the same theory, right? You start with the theory, you start with the data, you go up to the theory that perfectly predicts the data that you have, and then you see if there's other things that you didn't think of before, you didn't measure before, you didn't analyze before, you didn't get the results from before. I see if I speak in particular ways, this thing responds better. At that point, you go look for those other observable implications. So like the trick is to make yourself vulnerable to being proven wrong as many times as possible. And then, hopefully not to actually be wrong. So.
Not a common problem I've seen in data analysis where people assume the data says one thing when it doesn't. Like your example of cell phones, determine how much people are exercising. I could be doing yoga 12 hours a day, and it's not going to show up on the accelerometer on my cell phone.
Yes, that's right. No, that's right. We need validation of what these things actually measure. Absolutely. Absolutely. Right. I mean, almost every time. Since basically the massive increase in big data is not about us having more data. It's about people doing what they were doing previously for their own purposes. And it just happens that when you put in a new finance system or a new HR system into your offices, it just spews out data, right? And so we can capture that. But it wasn't created to do the data analysis, right? Like, I think companies now have a VP for technology or like or a chief technology officer. I think they all ought to have a chief analytics officer. And frankly, the IT guy ought to report to the chief analytics officer. So that way, when you put in the new IT system, or you put in the new finance system, or you put in the new HR system, it's tuned to the data that's going to come out the other end. But satisfying the needs of the HR system is not that big a deal, right? It's important, but it's not that big a deal. It's sort of well known. We just make sure it's satisfied. But the benefit you can get from it is just so much bigger. So, anybody else? Cool. Okay. There's one other thing that I want to mention, which is, in most fields, there's a quantitative-qualitative divide. In all the social sciences, and social sciences are basically the areas that study people, which is it's very, very large. In every one of them, there's this quantitative-qualitative divide. I remember years ago, I gave first time I ever gave a talk at the Centers for Disease Control. I had never done any work in public health or medicine up until that point. This was a really long time ago. And they called me up and they said, would you give a talk? And I said, sure, that'd be really cool. And they said, what would you like to talk about? And I said, how about this talk? And it was, a paper filled with math. And they said, no. And I said, well, how about this one? And there was this really cool statistical thing. And they said, no. And I asked them like 6 different proposals. And they said, no. I said, here's my CV. You pick something. And they picked a book that I wrote about qualitative methods. And I thought, who are you guys? I thought you were like 12,000 people walking around with lab coats. No, it turns out if you're in the Centers for Disease Control and you're studying, let's say, sexually transmitted diseases, we have to ask exactly how you have sex. I mean, like exactly, like with precision, right? You don't do that with a survey on a telephone, I don't know how you do it, but I don't want to know. So I think what's coming with big data is actually the end of the war that exists between the qualitative and the quantitative people. Inside law, inside medicine, inside political science, economics, sociology, anthropology, psychology, and inside many companies, there's a war. There's a simmering war between the qualitative people and the quantitative people. Do you find a similar thing? Like there's the qualitative, detailed experts that. Armchair experts, we might call them, the pundits, but they know what they're talking about, right? They may get it wrong, but they know a lot of the details. And then there's the sort of quantitative hackers that that sort of go for it, right? Don't know the details, but they can do an amazing amount of stuff with their technology. There's always a war between these two in every field that I've ever. I think this war, of course, it'll continue forever, but to some extent, it's ending. So the qualitative researchers are overwhelmed by information. They can no longer make the case that, well, we'll just read this book and this source of information, and we'll steep ourselves in the knowledge, and we will just understand it really well. That was a good question. Why don't you repeat it? Yeah, it's just, I mean, it is right for small things, but the amount of information is so large now, it's just not going to happen, right? You tell me what's going on social media this week, right? Try that, okay? Quantitative researchers recognize the huge amounts of information in qualitative analyses. So what do? They have field notes. They have video records of the detailed qualitative information they're collecting and audio. The key difference is that we're getting to the point where this stuff is basically data, right? And we can help them. Right? It's hard for us because we don't know how to analyze all that stuff, but we're getting to the point where we can analyze video and audio and unstructured text and things like that. And we can give them tools to make it better, and we can recognize that what they do is actually really valuable because they're basically collecting data for us. So.
Is it creating nice graphs, bridging the gap between quantitative and qualitative? How do you spend on that?
Yeah, so nice graphs is the question. I mean, I think I think it's incumbent upon us to take our results and make sure that other people can understand them. Okay? I mean, I think it's really important. So it's not right to require, sorry, I just want to, I don't know if you hear the banging, but it's not right for us to do some complicated analysis and then write it up in a way that nobody really understands but us, right? Or to say, this statistical technique has coefficients that are uninterpretable, so I'll just look at the p-values or something, right? Actually, what we do can be expressed to actual human beings. And we just have to figure out how to do it, and graphics is one way. There's others. But I think when you have an audience, it's like, you're teaching, right? It's not fair to require the students to first learn your language and then you'll communicate with them. You have to go to them. So.
Well, what about, say, the Google versus Apple argument? Google is incredibly data-driven, that moves them every day, but they could never have invented the iPhone.
Right. But they could continuously improve it. They could collect an enormous amount of data and learn what every feature of the iPhone is and how people use it and whether they like it and how they interact with it and whether they engage with it more and things like that. So, I mean, the fact is that we're never going to completely replace the qualitative people, right? Because an algorithm that has no human inputs is really not going to work. Right? Well, it's really, I'll talk about this in a little later, but it's really we're not going to fully automate anything. We're going to make things we're going to empower human beings, provide computer-assisted technology rather than replacing them. I mean, if we can replace some of them, especially certain ones that I would rather not mention, that would be a good thing. But actually, in fact, for the most part, we're going to empower them. And people. I mean, I have this experience going into fields or areas that are not used to quantification. Right? In fact, they actively don't like it. They think it's a horrible thing. And so we have to deal with the political issue of getting to them, communicating to them, explaining that no, they're not going to be devalued. We're not going to drop all the important things that they do. We're just going to make it a whole heck of a lot easier to do what they do. Right? And they're going to be able to do what they do far better. So, okay.
What do you think of the data visualization as an art form?
Think of the what?
Data visualization as an art form?
Yeah, I think it is an art form. I think that's a good way to do it. Yeah, I've been watching the sort of info-viz literature and things like that. So let's take like a word cloud, right? So what is a word cloud? It's really cool. Is it useful? Well, let's see. What's the number of word clouds that have been published in the academic literature? I don't know, 3? Like in all of the academic literature, you almost never see it. Why is that? Because it's cool, but it's not useful, right? But that doesn't mean we shouldn't use it, right? So it's an art form, that's right. So unfortunately, the way human beings work is we require useful and we require cool, right? We require engaging. Engaging is important. It's not sufficient to just be useful. So like, I'm not teaching this. I'm explaining like what I learned. Like, like that's why it's cool to have. That's some of the reason why it's cool to have graphics move around and respond differently to different people. Because engaging is important also. After all, why don't you just stay home today and watch this on a video if there's a video, or I guess there's a camera in the back. Why not? Well, the way human beings work is that there's something about being there that matters. Right? And that's different. We go to concerts. We don't only buy the DVD, even though the DVD is probably clearer, higher fidelity music. Not that there's any rock star here. Okay. Okay. So I think that's so I think yes is the answer to that's a long yes to your question. But okay. So I think this is going to end. I think this qualitative-quantitative divide is going to end. I think instead of the qualitative people being holding up in the other part of the building, I think more and more they're just going to come to us for advice, and that's sort of what I find that's what's happening, and that's a really terrific thing because we can get an enormous amount of information from them, in addition to their jobs and research funding. Joke. Okay. Thank you. It is the case that whenever we get to the point when we have enough information to quantify what it is that we're studying, when we have enough, and when there's an outcome that's measurable that we're trying to get to, and there's a contest the purely qualitative types versus, not the quantitative types, but versus the computer-assisted qualitative types. That's sort of us. It's the latter that win. So I can give you lots of examples. Two colleagues of mine took all the Supreme Court, all the cases that were argued before the Supreme Court in 1 year, and they collected 86 law professors and other people from law firms and jurisprudent lawyers and things like that, and they predicted the outcome of each Supreme Court case. And then, of course, there were a couple of people that looked a little like you and me, and they collected 6 crude variables, and they went in the back room and put together a little model. And I think you know how the story's going to end. Okay, right? There was no contest between the people who had devoted their lives to understanding the detailed jurisprudence of each of these Supreme Court cases, and the guys with 6 variables measuring the cases. Okay, and you're all smiling. First of all, because you feel good about that, but second of all, because you're not actually surprised, right? You can do this in field after field after field after field. Those guys that we just vanquished, they actually know a lot still. Okay, so but on this very specific task and tasks like this, we're going to do very well. Okay. Okay, so I'm going to give you some examples of my own work. And so the first one is how to read 1 billion blog posts and classify deaths without physicians. And the reason I give you this example is because I love to utter that sentence, because nobody else ever has, right? So these are 2 completely different examples, which, as it turns out, have exactly the same underlying math. It took me a year to recognize that, but that's actually what it was. And again, it's all in the analytics. So I'll give you an example. So first of all, how do you figure out what people are dying from in countries without autopsies or medical certification of death? Okay, so in the United States, when somebody dies, there may be an autopsy, or if there's no autopsy, there's some medical personnel that signs a death certificate. In most of the world, when somebody dies, they just go off to the bush and die, and is never heard from again, and that's all. Okay, there's no record of them. There's nothing. It's just that's it. Okay. However, it is in those countries when we really need to know what people are dying from, because the diseases are worse. There's infectious diseases. It might come here, right? I mean, we really need to know. Okay, we need to know because the World Health Organization will devote dollars to try to figure out and solve problems in different areas. Researchers need to decide what diseases to study. I mean, it's really important. So anyway, how do you figure that out? One way you figure that out is you do a verbal autopsy study, which is a good idea. What you do is you take a random sample, to the extent possible, of households where somebody died, and then you ask them a list of symptom questions about the person who died before they died, right? You say, did the person have bad stomach pains? Were they bleeding from their nose? Were they in bed for a long time? Did they have tire tracks across their back? That's right. And then what happens? Okay. And then what happens is you give the list of answers to a physician. The physician looks down the symptoms and says, I know what that is, tuberculosis. I know what that is, malaria. I know what that is, etc. And that works fine, unless, of course, you give it to a second physician. These are the qualitative experts, right? If you give it to a second physician, they also give you an answer, but unfortunately it has nothing to do with the first answer. And if you give it to a third physician, it's often completely different than the first 2. And so basically, you can't do it by expert. And you say, okay, well, let's get a better expert. So if you get an expert from, let's say Boston, like a really good expert, what happens is it's worse. Because if you see sniffles and you're a Boston doctor, you don't think malaria, right? Because there have been 0 cases of malaria in the United States in the last year. So you think you have the wrong priors. You just don't get it right. Okay. Alternatively, you can get the best doctor from Tanzania, and then what will you have done? You will have taken, remember there's a massive shortage of doctors in these areas, so to do our little research study, you will have taken doctors off the street and killed lots of people. Not a good analysis. That does not work, okay? I mean, it's the right source of data, but the way it was done doesn't work. I'll give you another example, and I'll come back to it. I'll come back to how we solved the first problem. Second one is sentiment analysis of unstructured text, like social media, by word counts. Okay. So what happens here is this is an area in which it works pretty well for a while, and then there's a catastrophic failure. Okay, so it's an area in which someone can do a little bit reasonably well, but a lot it's very hard to do. It's quite unlike, I don't know, heart surgery, where you don't do a little bit of it, you know, right? It's not like you sort of don't feel right at dinner, and you say, could you pass the dinner knife? Let me just fix that, you know, right? You know, so in sentiment analysis, you could do a little bit of it, and it could work, but you do more in this catastrophic failure. So my favorite example is some guys that were trying to predict unemployment rates. When, you know, the US would release unemployment rates, there's information in that. You could trade on it if you could predict ahead of time. And so what they did is they counted the number of times from Twitter and Facebook and other publicly available social media posts that there were words used like jobs and unemployment and classified ads and work and things like that. And they noticed this correlation. One went up, the other went up, and they were observing this correlation. They started investing and seeing where they'd make money. And then one day, there was this enormous spike in the number of uses of these words, and they thought, we got it. And they started putting all the money in, right, and predicting unemployment rates. And they didn't quite note that Steve Jobs had died that day, and his last name actually had a different meaning, right? You know? Right? So that's the problem with sentiment analysis by word counts, right? It'll work a little bit. It's plausible that'll work, and it's also plausible that we'll have catastrophic failures. Okay, so why am I telling you these two completely different examples? So it turns out that they had, for us, the same analytic solution. The key to both methods, as they existed, as I just described them to you, is classifying. So they're classifiers. You all have experience with classifiers, okay? So in the case of deaths, we take an individual death and we try to classify it in one of 30 categories of cause of death. In social media posts, we try to classify it into what the meaning is, okay? And you can do that by hand, perhaps, that's a question. And then we can take the training set of people putting them in by hand and trying to predict what it would look like. The interesting thing is that although what we're doing with these methods is individual classification, what we care about is not individual classification. On Twitter, no one cares what StatPumpkin222 has to say, right? We only care what everybody has to say, right? Not what anyone has to say, right? And so where our methodology is classifying individual posts, our goal is estimating the aggregate percentage. That's an important clue. For verbal autopsies, what we're trying to do is by physician, classify individual deaths, but that doesn't work very well. And what we're only interested in is not, people in medicine care about you. People in public health, they don't care about you. They only care about everybody, right? They don't care about anybody. They only care about everybody is the right way to say it. In fact, the verbal autopsy analyses people have tried to automate that without the doctors. You take a training set from a hospital where you know what the cause of death is. You fit some machine learning or statistical method to that. You take it out of sample. You port the coefficients over, assume that it's the same. Plug in the symptoms and try to predict the cause of death. Okay. And how well do you do? Well, how well do classifiers do? 60, 70% accuracy, something like that. You talk to people inside Microsoft, Google, almost most of these firms. In the wild, generically, that's about how well classifiers do. For a lot of purposes, that's terrific. Okay? If you're interested in the percent in a category, that's known as a disaster, right? If 10% of the people are dying dying due to cause one, if that's your estimate, that 10% are dying due to cause one, but actually you're 60% accurate, so it's 10% plus 40%, and the errors happen to be in that first category. And so the true answer is 50%, and so all the public health dollars go this way, and all the people go this way. That's a disaster. Okay. Same thing for sentiment analysis. You're trying to analyze what people don't like about the iPhone, and 10% of the people say it's because it doesn't have a physical keyboard. Right. That's your estimate. But if in fact it's 10% plus 40% or 50%, useless information. Okay. So what we realized is that we could estimate the percent in a category in a different way than estimating what category each individual post or death was in, right? So the way you'd estimate the percent in a category, the way we all did, is you'd run a classifier, and you'd classify each individual post or death, put them into the categories, add them up, and calculate the percentage. And then we would ignore the individual classifications. right? It turns out that you can estimate, that's what we figured out, we can estimate the percent in a category really accurately in an unbiased way without estimating the individual percentages. I realize it sounds like magic, and without the math, it is. But it's not. It works. I'll give you a little bit of intuition. So suppose you're interested in, let's say, let's take all the pairs of countries since World War II for every year. So there's about 1 million year country pairs, about 1 million. Which ones of those are at war? There's about 1,000 out of the 1 million that are at war. So imagine we train a classifier to predict which pair of countries are going to be at war. What does a really good classifier say? There's never any war. Never any war. I'm at 99.9%, right? You know? So that's very useful for certain purposes, but if you're interested in the prevalence of war, that's totally useless. Okay? So the key thing is a classifier is trying to get the percent correctly classified as high as possible. It's not trying to get you an unbiased estimate of the percent in a category. So we tuned a method to give you an unbiased estimate of percent in a category.
You mentioned that you do a lot of things based on analytics, you improve the algorithm, and do you have a classifier algorithm as a favorite or a starting point? For example, do you like SEM?
So the intuition seems to be you use an ensemble of as many individual classifiers as possible, and that's what seems to work the best. But my personal strategy is whenever possible to avoid the classifier entirely. So like change the subject, right? You know, and answer a different question. And for public health, we didn't care, you know, they don't care what anybody dies of. They only care about the proportion of people who die of particular causes. If you're analyzing Twitter or social media in general, you probably don't care what any one tweeter, Twitterattery? You don't care what any one of these people have to say. You only care what they all say. You only care about the percent saying that they don't like the iPhone because it doesn't have a physical keyboard, right? It's the percent that we care about. And so we developed a method that will give us unbiased estimates of the category proportions, and it turns out to work in both cases. I realize it sounds so simple here. Actually, we did this for the verbal autopsy analysis, and I was working on the sentiment analysis case for the U.S. presidential election for Obama's first campaign, and nothing was working. I mean, I was doing a data analysis project. We had no intention to develop new methods. We just wanted to use the off-the-shelf methods that computer scientists had come up with to analyze, to do sentiment analysis. And we're just trying every possible method, tried every possible classifier we could try, and it was just a total disaster for what we were interested in. It was just totally and completely useless. And we literally worked on that for like a year, and then like one day, I realized that, you know what, we've been doing this for a year, this is really dumb. The same exact project that we had figured out and totally works for verbal autopsy, the same methods that we're using for verbal autopsy turns out to work perfectly fine, or should work perfectly fine for the analysis of text. And it did, I mean, which is why I get to give this part of the talk. This is massive selection bias. I'm only telling you about the projects that worked. So we came up with this method, and the method led to we actually patented it. Harvard University licensed the technology to a firm in Boston called Crimson Hexagon. I mean, it was a startup that I helped found, and the reason this is CNN talking about it, and I especially like this. It says that Crimson Hexagon was named the 7th most innovative company on the web, and the reason I really like that is because my brother, who works at Microsoft, I told him about this because at Microsoft, on the same list, they were named the 9th most innovative company on the web. Isn't that great? Who knows how they come up with these lists? You know? Anyway, so that was the sentiment analysis, and then with the verbal autopsy thing, we now have worldwide estimates of cause of death by country, cause, sex, region in some cases. So it's the same analytics. Two problems that are so different, nobody in each field knows about the other. I mean, we cite, well, it's ourselves, so we cite our own paper, but that's the kind of thing. And so you figure out the analytics, you can solve different kinds of problems. Okay, I'll switch topics. Tell you about Social Security. Social Security is the single largest United States government program. It lifted a whole generation out of poverty. It's extremely popular. Its solvency depends upon mortality forecasts. Some other things too, but it depends upon mortality forecasts. So if retirees live longer than the Social Security Administration expects, good for them, but not so good for the Social Security Administration. And not so good for them because they're not going to have any money later on, okay, because they're not going to have Social Security. It basically becomes insolvent. The trust fund runs out. Okay. So Social Security must forecast mortality, and it must be reasonably accurate or there's going to be a big problem. So what about Social Security data? There's actually little change in the data, in the substance of the data for 75 years. You know, more data comes in. It's basically data on mortality, right, by age and sex and cause and different regions and maybe some other countries. So this is not actually an example in which there's big data. There hasn't been more data, right? So what about the Social Security Administration, that's SSA, analytics? Well, for 75 years, they've been actually doing the same thing that they've been doing. The same methods of forecasting mortality they were using 75 years ago as using today. So we were actually the first to be able to replicate what they do, to figure out how the Social Security Administration makes its forecasts. No academic paper had ever claimed to be able to replicate how they make their forecasts. No non-academic paper had ever claimed that either. The only people that have ever claimed it is the Social Security Administration. Okay. So there's a few other groups that try to approximate it, like this Congressional Budget Office and things like that. Okay. What they do basically is a linear projection. And then at the end of the projection, they look at it with a committee and they say, nah, let's erase that and move it over here. Okay. Okay. Now, there's two aspects of that. So the first aspect of it is that the linear projection is actually the best they could do given current technology. Okay, so fair enough, at least current technology a long time ago. And the erasing thing, actually that makes sense given that the linear projection was pretty lame. Okay, so if you and I were charged with making forecasts and those were the only methods available, we would also be doing some erasing and talking to the qualitative experts. However, as you and I know, we want to find some way of formalizing the forecast so that the qualitative experts can't be influenced by, let's say, the politicians, right? The Republicans would very much like to cut not the whole program, but quite a lot of it. The Democrats might like to extend it. And so you can imagine the pressure that the forecasters are under, okay? I can't tell you the pressure that they're under because we don't know exactly. They're not willing to talk about it so much. But, you know, you can imagine, okay? And so even if they are the best scientists that exist, they are still human. And we know that human beings make, you know, in the process of this, they're going to have to make many very small decisions. And when a human being makes many small decisions, you bias some of them imperceptibly, perhaps, in your favor. No matter how much you want to be unbiased, just the way we are. That's the way we were constructed. Okay. So no matter what, this is not a good plan. So we came up with anyway. Oh, the methods, of course, linear projection. They ignore things like smoking, which has declined quite substantially over the years. They ignore obesity, which actually has gone exactly in the opposite direction. And they don't cancel each other out. I mean, there's big changes in what we know predicts mortality. They don't use those. They use them qualitatively, but they don't use them in their formal models. Okay. So it's mostly informal. The forecasts, which is really terrific because they actually have made forecasts over the last 75 years. They're legally required to make forecasts. And so we went back and we got the forecasts and we saw, and then we waited like for decades to see how long, we didn't wait decades, but we looked ahead decades to see how well they did. They didn't do so well. Sometimes they did well, but pretty much they're logically inconsistent. Sometimes older people die, according to them, at lower rates than younger people. Not really right. Their forecast intervals are very, very optimistic. That is, they're overly optimistic. So it's really not a good approach. So we developed some customized analytics just for this problem. So this is the kind of thing that you do, including the specific methods, the specific problems that exist in the data, and we tried to tune it just for this problem. And the result is we get logical consistency. So, you know, unfortunately, older people have higher mortality. We get more accurate, he's going to be okay, don't worry. We get more accurate forecasts, so far as we can tell. And the result is, flash, flash, flash. There was a New York Times article. We wrote an op-ed in the New York Times. I don't know if any of you saw it, but they filled out the whole page with all these cool graphics, as the person over there asked about. But we didn't do the graphics. They did. New York Times does really terrific graphics. And we said in the New York Times that the Social Security Administration needs $800 billion more than they realized. And we've subsequently rerun the data with just rerun the analyses, same exact analyses, but just updated data since more data have come out. And now it's $1 trillion more than they thought they needed. As a side point, if they deal with the problem now, which seems impossible in Washington, but if they deal with the problem now, it's a relatively small adjustment. They slightly increase the retirement age. You'll have years to deal with it. They slightly reduce the benefits. They slightly increase the taxes. We could all cope with it, okay? If they wait until it's a big enough problem, it'll be catastrophic for everybody, okay? Anyway, side point. What's that?
Guess which one they're going to do.
Yeah, that's right. They're going to wait. And this, of course, other applications of the same methodology. Okay. Last methodology, I have two examples in this last methodology, is reading and writing technology. So writing technology about how we write, like write books, has changed big time. Several hundred years ago, we would be using a quill tip pen and some expensive parchment in front of us, right? Now what do? Well, some people use Microsoft Word and Google Docs, and those of us who are real people use Emacs and LaTeX, right? So there have been big improvements, okay? But what about reading technology? Reading technology has not changed very much. I don't care how many speed reading courses you've taken, you don't read much faster than the people that haven't taken the speed reading courses. Let's say you read twice as fast as them. That's still basically not faster than them relative to the amount of increased information that you have to read. 50 years, 100 years, 300 years ago, what would you do? You would get a book. You'd be given a book, and you would read it from cover to cover, and you'd be thrilled that you got that book. And then you would return the book, and if you were good and you worked really hard, you might get another book, and you'd read it cover to cover. Today, for work, how many people have read a book cover to cover in the last year? But for work, it doesn't happen. What you do is you do a Google search or search through the documents that you have. You get several hundred articles that are about the subject that you're interested in. And then what do you do with them? Well, you start reading them. You don't read several hundred articles, right? Because you're busy, right? You read a few of them, and then you read a couple more. And then at that point, you delude yourself into thinking that you understand all of them, okay? With a non-random sample, okay? Okay. One sec. What are we going to do about this? Okay, so the goal here is understanding from unstructured text, unstructured data. Unstructured data is the hardest part of big data. It's not packaged up nice and neat. Moreover, more data is not helpful. In fact, it's exactly the problem, right? So the fact that there's big data now, the media thinks, oh, there's big data, all of our problems are solved. No, no, no. Big data is big problem, okay? You need big analysis to solve big problem, okay? Okay, so this is a project that we're working on. It's called Consilience. Actually, I can say the patent was awarded today. So. Which is just, since it's not actually a product that you can use, it's just an indication of how long it's taken us to actually bring it out to make it usable, but we're getting there. We call it consilience, which is an old word that means the sort of jumping out of knowledge from information. Here's the basic idea. To understand many, many things, documents, whatever it is, human beings create categories, right? If your boss said to you, okay, here's a bunch of documents, tell me what's in them, what you would do is you'd say, after the end of the day, you'd say, you know what, there's 5 things here. Here's 5 categories of things. Here's what the 5 things are. That's just the way our minds work, okay? So we use the categories to represent insight and conceptualization. So what I'm interested in is the insight and conceptualization. In fact, most firms have essentially fixed categorization schemes, fixed ontologies to tally customer complaints or reports or information, and they require you to put the information into those categories, okay? So here's some bad analytics. Unassisted human categorization takes too much time. And the interesting thing is, you remember that your company requiring you to use that drop-down box to put the stuff into that category? Why are they doing that? They're doing that because if you choose a different categorization scheme, they or you have to go back and recategorize all that stuff over all those years. So you spend most of your time trying not to innovate. But the one thing you're good at is innovation, and the one thing you suck at is reclassifying millions of documents. Okay? Right? So this is crazy. Right? This doesn't make any sense. We're doing exactly the things the computers should be doing, and nobody's doing the things that we should be doing. So another way of analyzing this stuff is not the way we're actually doing it, but the way some people try to do it, which is cluster analysis. People have had experience with cluster analysis? Yeah? So what is cluster analysis? You throw in a bunch of documents or objects, and the machine produces this, right? And then it produces a set of clusters, and it says this is what these things have in common. And my experience is that most people have tried this. They try it because it makes so much sense. I have so many documents, I don't know what to do. I need a set of categories I can use to explain to people, and so we'll throw it into the magic cluster analysis machine, k-means, whatever it is. And out comes a set of clusters that are totally meaningless to us. Anybody that have that experience?
It's so fascinating. You sit down and try to figure out, why did it do this? You get insights from that.
Yeah, that's true. Why did it do this? Right, like you get things like the long documents are over here and the short ones are over here. Right? And it's not crazy. It makes sense that that would happen because who came up with these cluster analysis algorithms? Well, it's somebody that looks a little like you or me in the basement 5 years ago. They didn't know, their optimization function has nothing to do with what we're after today, right? They don't know what we care about, right? So there's no way that they could accomplish what it is that we're after. All right. So we have an alternative. The alternative is not fully human, and it's not fully automated. It's computer assisted. So computer assisted categorization. So you decide what's important, but not on your own. Because a big stack of documents in front of you, you're not going to be very useful. Okay? But you get some help. That's the basic idea. So we innovate. We classify fast or by computer, and we let you spend most of your time innovating. And we encourage you to come up with classification schemes as fast as you can with help. I'm being vague about exactly how it works, just because I'm not giving the math. But there's basically a UI. I'll give you all access soon. And the computer categorizes. Okay, so and then from our experiments, it's easier, faster, better, tastes great, less filling, et cetera. Okay. So there's lots of technology here. If you go to my website, there's a published article, so you can see exactly what it is. And soon we'll have a program that works. Okay. So let me give you some examples, so it doesn't just seem like all smoke and mirrors. Okay. So first of all, we're interested in what members of Congress do. Now, I realize the correct answer of that is absolutely nothing. Okay. But you're afraid when they actually do something. Right? Yeah. Okay. So what members of Congress do is of interest to political scientists. It's of interest to everybody, but political scientists study this. I'm using this right now as an example of this technology. So we got a data set of 64,000 press releases. That's what members of Congress say they do, which can't be that far from what they actually do. Oh, come on. What do political scientists say that members of Congress do? They say they do three things. They say they do advertising. Look at me, I'm a member of Congress. And why do they do that? Because name recognition turns into votes. They do position taking. Look at me, I'm a conservative Republican or a liberal Democrat. Why do they do that? Because they're tuned to their constituents, and having the right political positions gets them votes. And the third is credit claiming. Look at me, I brought this bridge to my district, or hack reduce to Boston, I guess, whoever did that. And why do they do that? Because when you do constituent service as a member of Congress, people like that, and they vote for them. So the three categories are basically look at me, and look at me. Right? So that's the categorization. If any of you have taken a political science class in the last 35 years, or an American politics class, you will have learned that that's the categorization, that's the topology, that's the ontology, that's in every textbook, every syllabus, every professor that teaches a course on Congress, that's what they teach, okay? Now, why do you need to know this? Because this is the example, and I'm speaking. No, just kidding. So what we did is we took the data and we put it into our computer-assisted clustering machine, not fully automated, not fully human, computer-assisted. And with this, our claim was that we could find insights that we wouldn't have found otherwise. So now, what is a claim? What is an interesting insight? An interesting insight is not a new insight. It's a new insight that my audience finds cool, right? That my audience finds interesting. Okay. So if you were studying what members of Congress do, you might be interested in something different. What I was interested in is my graduate student and I want to write an article for political scientists. So we're going to find the insight that political scientists are going to find cool. Damn it. Okay. So we looked around. First thing we saw was what we actually see, which is advertising position taking credit claiming, right? We see that. You can see that it's very apparent. It's not a surprise, but it's also useless to us because we wanted to publish an article in political science. That was our particular goal, right? Your particular goal might be making sure that your boss understands what you're doing. It might be understanding the features of your product that will go to market better than other features, et cetera. What insight is depends upon the person. That's the key point, right? No automated method could get this without you. Okay, so we first saw what was already known, not interesting. Then we saw topic. So there are some press releases about the economy, and some press releases about energy, and some press releases about the environment. And that was a set of categories. And you know what? That was different than what political scientists saw, but it didn't seem very interesting to us. And I don't think political scientists or anybody else would be that surprised because it's pretty common, right? So we kept looking. And then we found what we think of as an insight. And when I show it to you, I think maybe you'll think it's interesting too. We call it partisan taunting. Right. This is another thing that members of Congress do, partisan taunting. So it was Joe Wilson during Obama's State of the Union address saying, "You lie," right? Or just another example, this is in a press release, Senator Lautenberg blasts Republicans as chicken hawks. And on the floor of the Senate, he's got a picture of a general and a chicken in a general's uniform, right? And it's basically members of Congress spitting on other members of Congress and kicking sand in their eyes while, by the way, they're trying to make sure the government doesn't go bankrupt. Okay. So how common is this, right? We found this insight. We thought, well, that's sort of pretty cool, right? How common is this? So we used the first method that I told you about that led to Crimson Hexagon, estimating the percent in a category. Now I know my percent. Now I know my category. My category is partisan taunting. What's the percent of press releases from United States senators? Imagine you're a United States senator, right? Get all dressed up and be really cool. What's the percentage of press releases that are essentially partisan taunts? The other categories are combinations of these things. Right. Okay. Yeah, I mean, it doesn't really matter. Okay. What's the percentage? These are press releases that it wasn't written by somebody else. It was written by the senator or by his or her staff. Okay. So 27% of senatorial press releases. More than 1 out of 4 press releases are basically about yelling obscenities at the opposition. Okay. So you can think that's interesting or not, but my political scientists, my audience, my people thought that was pretty cool. Okay. Yeah.
So these positions, are you keeping them separate completely because those position taking will usually feed into people talking that are the other side?
That's right. So we have to define.
I wouldn't say it's on fire.
Yeah, that's absolutely right. So I'm skipping a few steps where we come up with coherent, mutually exclusive, and exhaustive categories that are coherent, sufficiently coherent so that people can read them, put them into a category. Someone else could read the same posts, put them into one and only one category, and they would be the same category as the first person. And so yes, there were a lot of steps. A few people asked me about validation earlier. That was one example where we worked really hard on that. That's right. And I'm being vague about what the categories were, but I promise, you go look at the article, and we were obsessive about proving ourselves, about making it possible to prove ourselves wrong, but we weren't. What's that?
I would think it would be much higher than that.
And well, think about it. Here. So when we came out with this, even before it was published, reporters would call me all the time, and they'd ask me this question. And I finally figured out how to answer this question. And I said, they said, is that high? And I said, well, it's only 1 out of 4. We think they do it all the time. I said, well, wait a second. These are people having a conversation, communicating in official, the 64,000 press releases is all press releases from the United States Senate for 3 full years. Okay, so is 27% high? Well, think about your own personal life. Think about, let's say, you don't write press releases, most of you, but you write emails. So how many of you send out? I mean, occasionally we send out an email that's essentially a taunt, right? It's it's some nasty comment about somebody else. Would you say it's 1 out of 4 of the emails you send? Right. I mean, I think that's a lot. That's a very large fraction of what politics is. Right. And it might be the case that people spend so much time doing this that it elbows out trying to solve the country's problems. It might be the case that citizens, why are they doing this? I think they're doing this to get the attention of their constituents, right? Because if you're in a conservative Republican district, taunting the Democrats, even if there are no Democrats in your district, might be a very popular thing, especially if there's no Democrats in your district, right? So it might be a good thing for them, but I think that it would be good if citizens were aware of one more fact about their member of Congress, the percent that they taunt. And that 27% is on average. It's different for different people. Some of them don't taunt at all. Some of them spend most of their time taunting. I want everybody to know. And I'll have you know that there's lots of my undergraduates that are working very hard on tallying this up, and pretty soon we're going to have a website with all of that information available. Yeah. That's a great question. We've been working on that for 3 years. We will soon have all the data back to 1989, which is not what you want. I want to go back to 1789. Because you know what? People always say, actually, whenever a member of Congress resigns, they always say the reason they resigned is because of the bitter partisan nature of it's very difficult to get things done because of how bitter and partisan everything is. Right? 200 years ago was pretty bad too. Actually, it's been pretty bad like throughout American history.
Duel on the floor of the Congress. I mean,
yeah, they're duels. Yeah, there's sort of physical fights. People, right? I think that's right. So, but I don't know. I want to know the answer to your question, and we'll find out. Okay. I mean, we'll study it.
What was the shape of the distribution? I'm wondering, could this be due to a couple of really obnoxious sentences, and everyone else is still alive?
It doesn't seem to be. There's a pretty. We estimated it using the methodology I described earlier, and it is sort of normally distributed. And there's some examples of senators that are the high taunters and the low taunters in our other article, but we're doing it very systematically. You can imagine if we release a website that says, here's a list of the biggest taunters, your constituents may wish to know this, that we'd better get it right. Or they will come and eat us. Yeah, does it go with those debates? Yeah, I'd love to know that. Is it worse just before election? Maybe, or maybe it's not bad just before. Maybe they try to get above the fray and be bipartisan just before an election. Right. Oh, yeah.
In any of your studies, do any of your results suggest actions that people could take to change policy to, say, fix problems or do things better?
Well, the Social Security example is, I think, yes. I'm not sure about this particular example, but I sort of think that if people taunt less and they actually have discussions more, I sort of think they'll be more likely to come to positive conclusions, but that's an empirical question we have to see. So I have my last example, which I'm going to show you, has more policy implications.
I mean, anybody who watches the British Parliament is not surprised by this, right? They spend all of their time talking.
Yeah, that's true. That's true. Although in the British Parliament, the majority doesn't have to pay attention to the minority at all, right? So that's, it's so interesting that they do it, right? Why don't they just ignore them? So, okay. Okay, so I'm going to change to my last example, which is the Chinese government doesn't just let social media posts be posted, they actually censor some of them. Actually, let me tell you how we were studying this. So, you know, I'm giving you 2 examples now of how we've studied methods for unstructured text, right? So we were interested in coming up with methods for unstructured text. We had a method, and we wanted to sort of field test it in a difficult case, and we figured, let's do it in the case of Chinese, because that, you know, if it works in Chinese, that'd be pretty good. And so we went and got some posts in a particular way. We got the posts, and we analyzed, tried our methodology, worked fine, okay? And then I said to my graduate students, why don't you go back to the website from which these posts came, and just make sure that we understand the context in which they are. Make sure we're getting the post, not the blog roll or some statement by the government or whatever it is. And they came back and they said, you know, Gary, I think the database that we got all of these posts in may be biased, may be wrong, because sometimes we go back to the website and the post is there, and sometimes the URL that we got with the post doesn't seem to correspond to the text, because we go back to the website and it's blank, or there's some note there or something like that. And we realized, wait a second, we have the text of the posts that were censored. What the Chinese government prevents the Chinese people from seeing, we can see. We have the text of all the censored posts. So I said, we're not going to write a paper about analyzing unstructured Chinese text. We're going to be writing a paper about Chinese censorship. Right? So I thought, that was cool. Let's figure this out. So the previous approach to figure out what the government was doing was they would look at, basically as an ant on the anthill looking out to see what was happening. You would see one post be up and then it'd be down. You'd see another post. You try to figure out what was going on, but it's very difficult to see what the big picture was. So, as I said, we get the posts before the Chinese can censor them. So we have a way of going to the websites, snagging them before the Chinese government gets them. This is through Crimson Hexagon, actually. They get all social media posts worldwide pretty much the moment they're posted. I think they have the largest collection of any firm anywhere. So we analyzed for this particular study, you can find it on my website, 11 million posts, about 13% were censored. Okay? So you can imagine this task, to do this task yourself, right? And suppose you had some goal about which ones to censor. There are 11 million posts, and you had to decide which 13% of those to censor. Okay, so the previous understanding, what everybody thought that the Chinese government was doing, was they'd censor criticisms of the government, and of people in the government, and of their policies. Seems sort of obvious, right? Because then the next person that would come to the pruned social media posts would find very positive statements about the government. Okay, so here's the results. They do not censor criticism of the government. They don't censor it at all. They were the most vitriolic posts about the leaders, about their policies, and about the government. The most vitriolic. I mean like no holds barred. Okay, like the leaders of this town, here are their names, are stealing money from the treasury. And they all have mistresses. It's real personal, okay? You know, I mean, it's really like very specific. In the past, what people said was when they would find criticisms of the government, they would say the censorship system, given how big it is leaky and imperfect. That's the quote, okay? It's not leaky and imperfect. It actually operates with military precision, okay? It's amazing how accurate it is when you figure out what it is they're actually after. They're not after, they don't care about criticisms of themselves, okay? So what are they after? They're after attempts at collective action. Any attempt to move people by anyone other than the government gets censored. If you say the leaders of this town are slimes, no problem. If you say the leaders of this town are slimes, let's go protest, stop. You're going to be censored. Okay? If you say it long enough, they're going to go pick you up. Okay? If you say the leaders of this town are wonderful people, they're working so hard for us, let's go and have a big party for them, censor. Okay? They don't want anybody moving people except for them. Okay? Which I thought, you know, like, we'd not thought this, nobody thought this. This was a surprise, okay? We used Consilience to figure this out, right? Because we had millions of posts that were censored. We had, you know, we had tons of posts that were not censored. We had to try to figure out, well, what the heck were these about? That's what we learned. We then, after having discovered that those were interesting categories, we went back and validated and tried to make ourselves vulnerable to being proven wrong. And this result is so clear, you don't need complicated statistics. It's really, really clear. So Actually, I'll mention one other thing about this, which is you can also look at censorship, rates of censorship. I mentioned about policy. So rates of censorship, like certain issue areas, they would censor very high, and some they would censor very low. And so Ai Weiwei, do you know who Ai Weiwei is? So if you remember the Olympics, there was this bird's nest-like stadium. So he was an artist, he's an artist, but he's also afterwards turned into a dissident, okay? So we were monitoring rates of censorship about Ai Weiwei, and they were really, really low, like 5%, 10%, something like that. And then one day, they went to 85%. So 85% of the posts about Ai Weiwei started being censored. There was nothing in the media about this. There was nothing, there was no public statement from the Chinese government. No reporter said anything. What happened? 5 days later, they arrested him. So what happened? What happened, we think, is the Chinese government decided we had enough of this guy, okay? And they send a message to the censorship folks. They say, start taking down anything about Ai Weiwei. And they wait a little while until they have total control of the information flow, and then they go pick them up, okay? Second example is in the South China Sea between China and Vietnam, oil was discovered. And China and Vietnam both all of a sudden took a liking to this sea, right? They both thought, this is a great place. We want to claim this as ours. And there's all this conflict between the two countries. They're shooting across each other's bow. They're ramming each other or threatening to. And rates of censorship are soaring. They're getting very high. Chinese government is very protective of its prerogatives in international affairs in particular. Very, very high. And the media is talking about, is there going to be a war? What's going to happen? They're constantly talking about that. We notice, because we're the only ones with a viewpoint from the aerial photograph rather than from the ant on the anthill, we notice one day that the percent censorship drops from about 90% to about 10%. Right? It just stopped. What is the media talking about then? Oh, are they going to go to war? What's going to happen? There's this big issue. Right? 5 days later, they signed a peace treaty with Vietnam. So we think what happened was they decided they were going to sign a peace treaty with Vietnam. They told the censors, just lay off of them, don't worry about it, everything's okay. And then they get around to it and they sign it. So like we could see things that nobody else could see before. And we have some other examples like that. So that's the policy implications. The US government was interested. So. Yeah.
So how do you validate all this classifier or your method is accurate? How do you validate? Do you have a different method of validation? How do you know your validation is accurate?
So we take our training set, we code, which was coded by hand. We code our test set by hand. We hide the test set, all traditional methods. We hide the test set. We make our prediction. Only we're not making a prediction about any individual post, because we don't care about any individual post. We only care about the percent in a category. Right? And then we see whether we get that right, which we've done many, many, many times. So, okay, last slide. So I'll just close with some good feelings. So we call it quantitative social science. You may call it artificial intelligence, data science, whatever the project, the joint project that we're all involved in. The question I like to ask is, what university research has had the biggest impact on you? Okay. Now, maybe it's the genetics revolution, right? They spent an enormous amount of money, okay? But actually, they haven't actually had much effect on human health. They may one day. We hope they will. We think they will. I'm glad they're spending money. But actually, they haven't really had much of an impact. How about this, the Higgs-like particle? Maybe it's a Higgs particle now, okay? Actually, it had a big effect on me. I thought it was really cool, okay? But it didn't really affect our lives, okay? Well, maybe it did, but only our sense of sort of wonder. Exoplanets, the Mars rovers, watch it every day, okay? Think it's totally cool, but to be fair, it didn't really change our day-to-day lives. Doubling life expectancy in the last century, yes. Okay. Yes, okay. And there's other things that deserve to be on that list, okay? But my only point is that one thing that I definitely think deserves to be on that list is like quantitative social science or whatever it is that we all do. Okay? Big data analytics, whatever you want to call it. What has it done? Well, it's merely transformed essentially all of the Fortune 500 companies, like completely changed what they are and how they make money. It's established whole new industries. It or we have altered friendship networks. We've increased the expressive capacity of human beings to more than at any point in human history. We've changed political campaigns. We've transformed public health. We've changed legal analysis. We've totally influenced crime and policing. Did you notice what happened here a few months ago? That wasn't done. That was done with big data, right? We invented economics. They may need to reinvent that again, but even so. Transformed sports. Sports, really. We set the standards for evaluating public policies. Public policy in the past was always one gigantic experiment with only a treatment group, right? And there's no control group. But governments now understand that there can sometimes be a control group. We ran an experiment in Mexico, which evaluated the equivalent of the Obama healthcare plan in Mexico, where we randomly assigned hospitals and doctors and money and insurance to communities with 500,000 people. And the government let us do this, not for fun, but because they would learn more. And they understood that the kinds of methods and procedures and causal inference techniques that we have are actually useful to them. They can actually produce better public policy. And so we've actually set these standards. And then there's also et cetera, and et cetera, and et cetera. So that was a pre-programmed joke. In any event, happy to take more questions, or there's a website up there, and these are some of my collaborators. Thanks a lot. Anybody want to ask or want to eat? Okay.
So you can't just mention that you ran an experiment on the healthcare without telling us something about the results.
Oh, so the key question in Mexico was, does the money make it to the people? Because you'd think, well, wait a second. They're spending a fortune. They're spending more than 1% of GDP on this program. Of course it's going to make it to the people. They're spending it on the people. It's not true, actually. The vast majority of public policy programs for the poor, what happens when they spend the money is the officials get better offices, they get nicer cars, there's a lot of more administration, and actually the poor people are still poor. Okay? And I actually used to say that was just in developing countries, because it's a disaster in developing countries. And my Mexican collaborators said, no, Gary. In the United States, and they knew the statistic on the top of their tongue. They said if you took all the money designated for poor people in the United States, and you got rid of all the programs, and you divided by the number of poor people, you'd have $35,000 per poor person. So anyway, the money usually doesn't make it to the people. So it was designed for that, and actually, so we studied that. We instrumented everybody, and it turns out most of the money actually did make it there, which was pretty cool. But we discovered some things along the way. So in order to get the benefits of the program, you had to be in the treatment group. Okay, you had to be in an area that was assigned to the program, and then in addition, you had to actually sign up for it. Okay, so the program was there. It was free health insurance essentially. So you'd think everybody would sign up, but these are human beings, right? Human beings don't always do what's in their interest, right? And so they didn't always sign up. And so the rule was everybody had to sign up, except for the poorest of the poor, all the way down at the bottom, they were signed up automatically. Okay, so it makes sense, right? These people definitely didn't have some other form of health insurance. They definitely could not care for themselves in other ways. So we're just going to sign them up automatically. So one thing that we discovered is, yes, they were signed up automatically. However, the way the money flowed in this system is the federal government would give to the states the right to affiliate a certain number of people to the program. And when they affiliated them, and they would only give them that right when they made the hospitals good enough, so that was incentive to build the hospitals, but then they would only get the money when they actually affiliated the people. Okay? So what happened was, what we discovered was, most of the poorest of the poor, they were affiliated, so they got the money, but they were not aware that they were affiliated. So the government didn't have to spend the money. So we discovered that, actually, and then they changed it, and so now the government only gets it if they're aware of it. And so that was a good result. So.
Give me estimates of the increase in efficiency of algorithms. Like certain scientific programs have seen like 10,000% increase in the effectiveness of their algorithms.
Yeah, I would love something like that that goes over, like something like Moore's law, but instead of like this, it would basically go like this, you know. I don't have it, but you know, you could probably do it in certain, you know, like sorting algorithms, for example, right? You know, where there's been steady progress over time or things like that. But so if anybody knows, if anybody comes across this, I'd love to hear from them because I'd like to add that graph to my talk. That'd be great.
Can you briefly describe the intuition behind calculating the aggregate percentages of large volumes of data without classifying the individual elements before aggregating?
So it seems impossible, right? It seems like the only way to estimate the percent in a category is to do individual classification and then add them up. Okay, so I'm not going to tell you how we did it just because it requires a little more math than this forum would allow. But let me give you another example of how we could do that. That's a little easier to understand. It's a lot easier to understand. So we have a gigantic test set, and we think that the only way to estimate the percent in a category is by classifying each individual post into the categories and then adding them up and calculating the percentage. Okay? Here's another way. Take a random sample from that big population, hand classify them, and use those percentages as the estimates of the whole population. So we didn't classify the vast majority of the posts, but yet we have an estimate of the whole thing. Moreover, those estimates have very specific properties. They're unbiased. So on average, they'll be right. Sometimes they'll be too high, sometimes they'll be too low. Unlike the percentages calculated from individual classification, which are not unbiased, right? Like if you say, well, no one ever goes to war, that's biased, right? Your spam filter is biased because you're more annoyed when you lose an important email than when a spam makes it into your inbox. So it's biased. We wanted an unbiased estimator. So we started with that, and we just have a much better method that doesn't require hand coding. So that's intuition, but not the answer.
Do you have an opinion on prediction markets like the old Intrade site, and do you consider that to be qualitative or quantitative?
Yeah, I remain to be convinced about prediction markets. The people who like prediction markets, they always say, it does better than public opinion polls. Well, what does that mean exactly? At the last minute, 10 seconds before the election, or whatever it is that we're predicting, it does better than public opinion poll? Actually, public opinion poll, we know exactly how well it does. It's if you have a random sample, which is a big issue because it's harder to do that these days, but if you have a random sample, we know the scientific connection between the data we have, the estimator that we have, and the truth, right? We know exactly how big the confidence interval should be, et cetera. For a prediction market, we don't really know. Moreover, what happens, you know, a year ahead of time? I'm just not sure. I want to see it validated more. So all the interest in validation here, I think it would apply there. I mean, I think there's good intuition as to why it should work, which is sort of revealed preferences. Put your money where your mouth is, you know. But I want to see, you know, I want to see that it really works, and that's sort of an open question. So,
Can you just talk a bit more about
About what?
your company, Consilience?
So it's not a company. It's a cool idea. You know, maybe it'll be company, but we're going to finish the UI first. So it's a software. It'll be a website that you can go to. You can put your data in it. You can do cluster analysis in a computer-assisted way rather than letting whoever came up with that algorithm invent it, decide what's important to you. You get to decide what's important to you. Roughly the way we do it is there have been about 150 clustering algorithms that one person has proposed and at least one other person has used. So that's my measure of what a clustering algorithm is. So one way of doing what I'm suggesting is you take your documents, run it through all 150, and then evaluate the 150. There's two problems with that. First problem is to look at 150 clusterings is too much for any one of us. Okay, it's just way too much. It's too annoying. So that's the first problem. Second, so it's way too much. Second problem is it's way too little because there's millions and millions and billions and trillions of clusterings that are not in that list of 150. Okay, so we solve both problems at the same time, the too much and the too little. What we do first is we scale the 150. If I showed you a list of 150 clusterings, or even a billion clusterings, and what we would really like you to do is look at the first one, then look at the second one, then look at the third one, and choose the one that's most insightful. Okay? But you just get bored too much. Okay? what we do is we organize them. An unordered list like that is too hard to really understand. But if we have an organized list, it turns out it's possible for a human being to look through. So an analogy is, if you had a list of 1 billion latitude, longitude points in Cambridge, ordered in a haphazard way, and what was there. So like at this latitude, longitude point, there's a bunch of people having a conversation. 200 yards that way, there's a bush with white flowers on it. And 6,000 yards that way, there's something else, et cetera. If we had just a list of those, and we had to get from the hotel to the restaurant, it would be really hard, possible, but really hard. And we would get bored before we got it. If, however, we take those latitude, longitude points, and we put them into a geographic map, all of a sudden we can get there. In fact, if we increase from 1 billion to 1 trillion, it just makes the map more precise and higher resolution. It's no problem. We can put an enormous amount of information in our heads if it's organized in geographic form, which is an interesting point. So what does that have to do with clustering? So we figured out how to take the 150 clusterings to start and put them in a map, not a geographic map, but a map. A map such that nearby nearby points in the space, each point being a clustering, nearby points in the space are similar clusterings, and faraway points are clusterings that are very different. And so what you can do is you can click on a point, you can look at the clustering. We have ways of figuring out what it is really quick. And if you think that's totally uninteresting, then you click on a point very far away in the space. If you think that point is sort of interesting but not quite what you want, you click on a point nearby in the space. And so it's possible to traverse the space. That's the first point. Second point is, so now we have 150 dots scaled in this way, where nearby dots are clusterings that are similar and faraway dots are clusterings that are far away. What about the white space? The white space are clusterings that are the results of cluster analysis algorithms that have not yet been invented. How to create them, right? Because all we need to do is take the weighted averages of the clusterings that actually were produced by real methods. And so we figured out a way to do that. And so we can fill the entire space with clusterings, right, with millions and millions and millions of clusterings. And just like a map that has higher and higher resolution doesn't confuse you, this doesn't confuse you either. So that's the rough intuition of how we do what we do. So. Oh, for sure. Even in my own department in political science, it used to be that the quantitative parts of political science basically just studied American politics for historical reasons. But political science also studies international relations, wars and stuff, economic conditions, and comparative politics, which is a sort of stupid name for places that are not America. And more of those methods have sort of gone out and out and out and out. The sort of last frontier of places that are sort of untouched is political philosophy. Is war just? Okay, let's give them a break. Okay. However, what a graduate student and I are doing is we've gotten all of the ancient Greek and Latin texts that these philosophers study, and we've put them all in Consilience. and so these are the most studied texts that human beings have ever devoted effort to, right? Because for 2,500 years, people have been studying these. And so our working hypothesis that we're going to try for is that we can come up with more interesting or new insights faster and better than other people, despite the fact that 2,500 years of scholars have worked on it. So anyway, that's the introduction to the article I'd really like to write, but I can't write it yet. and yes, in every different field. By the way, there's a seminar at Harvard Wednesday at noon that you're all invited to. Don't all come on the same day, but but quite seriously, you're all invited to. If you send me an email, I'll get you on the mailing list. It's a seminar in applied statistics. We bill it as a tour of Harvard's statistical innovations and applications with weekly stops in different disciplines. And so we literally go from field to field to field to field. And the cool thing about it is that we have the language that translates from one field to another, because it's also the methods and the math and things like that. So we can figure out how to translate from one language to the other if you can just figure out what the model is. And so yeah, it's the march of quantification that has gone from field to field to field. It hasn't gotten that much to art history, but will, no doubt. So.
Outside of your website, is there a particularly good text or journal to sort of be up to date on the latest?
You mean this thing's outside my website? Is it? No. So in my field, yeah, it's big data. So that's a big question. In my field, there's a journal called Political Analysis. It's not only about politics, but it's the subfield of political science that's methods. The cool thing about this field is that there's the field of statistics, there's the field of econometrics within economics, political methodology within political science, psychometrics and psychological statistics within psychology, biometrics, bioinformatics, biostatistics within biology and biomedical sciences. You can go on and on and on and on. And our implicit strategy has been divide or be conquered, right? So we've divided ourselves up, and we exist as these growths within these fields, and we're all becoming bigger in each of these fields. We're all becoming bigger, and we're also connecting across fields. So a great way to be interdisciplinary is to study methods. Actually, I'll just tell you one story. When I was in graduate school, my professors would say, "So Gary, you know, you're doing something in this field, and you're doing in this field, and you're doing in this field. You're sort of scattered, you know." And as an academic, that's like, you don't do that, right? You be like a bench scientist. You study one molecule for 15 years, you know, and you're sort of scattered. And so finally, with some others, I helped convince them that, you know what, there's another field. It's political methodology, right? It's the methods field within political science. And then I realized I finally had succeeded when one of them turned to me and said, "Oh, I get it. You're not scattered. You're narrow," right? Right? Because you do methods, right? You know? And I said, yes, I'm narrow, right? Because that enables me to study whatever it is I want. Right? And it does. It's like we all have a tool that gives us a seat at the table, which is really cool. You know? Thanks so much.